Let's go to forces and energy, page 18. Looking at acceleration and calculating acceleration. Calculating acceleration. Acceleration describes the rate at which velocity changes. If an object is not changing direction, you can describe its acceleration as the rate at which its speed changes. To determine the acceleration of an object moving in a straight line, you calculate the change in speed per unit of time. This is summarized by the following equation. So, go ahead and highlight the equation for acceleration. It is the final speed, so the speed you end with, minus initial speed, or the speed you start with, and divide that by time. Let's talk about that example. If speed is measured in meters per second, we would label it m/s, meters per second, and time is measured in seconds. The SI unit of acceleration is then meters per second, or they sometimes write it meters per second squared. That will be the label for acceleration. Suppose the speed is measured in kilometers per hour and time is measured in hours. Then the unit of acceleration is kilometers per hour, or acceleration can be kilometers per hour squared. So to understand acceleration, imagine a small airplane moving down a runway, like in figure 2. That's this. It shows the airplane's speed at each second of the first 3 seconds of its acceleration. So to calculate the acceleration of the airplane, you must first subtract the initial speed of 0. So here is 0 is its speed at 0 seconds. At 1 second, it is going 8 meters per second. At 2 seconds, it's traveling at a speed of 16 meters per second. At 3 seconds, it is 24 meters per second. And then we need to calculate at 4 seconds. So going from there, to calculate the acceleration of the airplane, you must first subtract the initial speed of 0, so there's our initial speed, from its final speed of 24. Then divide the change in speed by the time, which is 3 seconds. So plopping it into the equation for acceleration, the final speed is in blue, that's 24 meters per second, that's found up here, minus 0, so what it started at, divide by 3. Punching that into the calculator, 24 divided by 3, acceleration is 8 meters per second squared. So the airplane accelerates at a rate of 8 meters per second squared. This means that the airplane speed increases by 8 meters per second every second. Notice in figure 2 that after each second of travel, the airplane's speed is 8 meters per second greater than its speed in the previous second. So here's what they're showing you is this is 0, at 1 second it's 8, then it goes up another 8, so 8 plus 8 is 16. Another 8 is 24. Go ahead, acceleration. The airplane is accelerating at a rate of 8 meters per second squared. So predict, determine the speed of the airplane at 4 seconds, and write it over here. and 5 seconds. And write that over here. Write your answer in the boxes next to each airplane. And then what about deceleration? An airplane touches down on the runway with a speed of 70 meters per second. It decelerates at a rate of -5 meters per second. So predict or determine the speed of the airplane after each second of its deceleration and write your answer in the table to the right. Go ahead and try that. Next, we're going to work on the math. Do the math. Large accelerations are part of a thrill in many amusement park rides. The problem below are based on actual amusement park rides. So, 1. Calculate. One type of ride falls straight down for 3 seconds. During this time, the ride accelerates from a speed of 0 meters per second to a speed of 30 meters per second. What is the average acceleration of the ride? So go ahead and pause and try and answer that. Initial speed equals what? Final speed, time, and average acceleration. Now let's try number 2. Calculate. A roller coaster accelerates from a speed of 4 meters per second to 22 meters per second in 3 seconds. So what is the average acceleration of the ride? Go ahead and pause and try and answer that question. Assess your understanding. Define. The rate at which the velocity changes is called blank. Infer. A softball has a positive or a negative acceleration when it is thrown, and then a softball has a positive or negative acceleration when it is caught. Explain. A girl skates around the perimeter of a circular ice rink at a constant speed of 2 meters per second. Is the girl accelerating? Explain. And try the I get it. Now I know that in science, acceleration refers to, find your answer on that one. And if you need extra help, mark here and ask for help from your teacher. Thank you. Till next time.